Have you drawn that yet?
Drawn in a minute.
Nearly, okay. You drew it? Amanda?
Mm-hmm.
You drew it?
No,
No?
because I don't calculate the
Roots.
no, not the roots.
No?
Next step.
Okay. I'll draw it now for you. So can everybody look up? So what I'll do is I'll put the 4 graphs on the screen and then you can check. So the one you were just drawn for me was y equals minus 5x cubed minus 24x squared minus 34x minus 21, yeah? So the graph you should have gotten was something that looks like this. That's what you should have. So it only has one root. Okay. Are you ready for me to draw the next one? The one that was part of your homework? Y equals 24x cubed minus 83x squared plus 79x minus 18. Can you see that in blue?
Which one is
Whoops. The red one is B. And the blue one is W, which is the homework. Okay, now time for X. Y equals X cubed plus 7X squared minus 5X minus 75. So this is X on your homework. Can you see there in black? And then if you want me to zoom out a bit, there it is. And then lastly, y equals minus 5x cubed plus x squared minus 3x minus 9. In green. So I just want to make sure you have the graphs on the screen. You can watch the video again later. You can see the graphs appear. You can check your answers.
it's beautiful or even good? Good?
I would say not ugly, you know.
The black one is X, right?
The black one, I don't even remember now. The black one is X. Yes, it is. But yeah,
And what about the green one?
is Y.
What green?
Okay, can I go on? You want to draw them?
Yeah.
Okay.
Student,
Yes.
can you explain the question for?
Question 4. Oh, the last one.
Yeah.
The Y. Do you want me to do it?
Yeah.
Yep. Okay. So let's have a look here. You have minus 5x cubed plus x squared minus 3x minus 9. Okay, so what do you do first? Well, we'll put in 0 and we get minus 9. So that's the y-intercept. Now let's get some roots. Well, I think I could try positive 1 maybe? No, that's no good.
Which one?
The last one. No, don't tell me. I can do this. Positive 1 is no good because that would be too big. What about negative 1 as well? 5, 6, no, I think it has to be like a 2. Maybe like, here, let me sub in some numbers and see. Okay, let's try with negative 2. Nope. Okay, let's try negative 1. Ah, there we go. So if I use x equals -1, I have a root. Okay, so what's the factor? That's x plus 1. So if I do my long division, I get this quadratic. Now, if I look at this quadratic, let's see, b squared minus 4ac is negative, so it has no roots, no factors. So it only crosses once. So let's just summarize what points we have. The first point we have is 0 minus 9. Can you see that there? Oh, sorry, it's gone. Can you see that there? 0 minus 9. The second point we have is minus 1, 0. That was the root here. And then we plot that. Can't even see it. There it is, there, the blue one. So you remember these ones here. Well, is it up, down, up, or down, up, down? Down, up, down.
Because negative.
Because it's negative. So the way I see it, we could go down through the blue one and up through the red one and then back down. Or we could go down to the blue one but not continue, go straight back up and then down to the red one. So the question is, we would like to know what happens after the blue dot, the -1. Do we immediately turn around and then go down? Or do we go down and then continue down? I haven't. Oh, sorry. No, I'm speaking wrongly. It's minus x cubed, so it goes up, down, up, isn't it? Or am I very confused now? Hang on. X cubed is down, up, down. Is that right? And then negative x cubed is up, down, up. Is that what I said?
The positive up, down, up.
Positive is...
Up, down, up.
Are you sure?
Yes.
Positive is up, down, up. And negative is down, up, down. Down, up, down. Now I think I'll go down to the blue one, up, and then down to the red one. So let's just put in a value of x to see. What value of x will we use? 1 second. What value of x will we use? You moved on. I can't see Grace. What value of x should we use?
No idea.
No idea. That's okay. You're not here yesterday. So who was asking me this yesterday? Was it Sophie or Amanda? You were telling me which x we can use if we want to check if it's down, up, down, or maybe it's down, up, down.
Oh.
What could we use for x? Well, what about minus 0.5?
Just put in the equation.
Yeah, let's use minus 0.5. And I get this number. Minus 6. It's just me picking a number here to see where my graph is. So if I use minus 0.5, this is a point on the graph. So let's see. You can see that here. So I think it will go down, it will continue down, then go up, and then go back straight down. That's how I would draw it.
How do you know it's going to go up after that?
It has to cubics. Cubics is down, up, down, so it has to curve. Alternatively, this point Fahad could have been up here. Then it would make me feel like it go down, up, down, but I don't think it would be this because then I would have two roots. So let's see what we get. I might be surprised. It might be none of these. Wait. Hang on. Yeah, the up doesn't really happen until after the 10. So it actually went down, up after the red. Now that's no big deal.
But you teacher, for this question, basically you have only 2 points, right?
Yeah, this is what's making it difficult.
So 2 points. I don't need to make the third one.
No, you didn't need to for this one. It just helps you feel better that you're doing it right.
But if I don't do it, it's still good, right?
Yeah, but you want to feel good, don't you? Yeah. By the way, there are other things we can do to help us draw this, but we won't learn about that until the end of the semester. So we will learn how to find the vertex, but at the end of the semester. So for right now, we have only small skills we can use to draw this. Okay? So it will be easier later. Yeah? The best thing is just to practice. If you want to download this program that I'm using to make my graphs, it's on the Moodle website on the ICT page. The program, you can see the name is called Derive. Yeah, you can download it if you want to draw a graph.
Please search on the Google, that is online graphs.
Or Google online graphs, what's his name, Alpha Wolfram or something. There's online websites for making graphs too, yeah.
That's good.
Okay, we'll continue now. I can continue? Yep, okay. So, we have seen, what's wrong? Oh yeah, what's your question here?
Is it positive, up, down, up?
You watch the video and you can get the notes you missed.
What I know, I think
You missed the class, so you get the notes. That's how we roll. Okay, next, what we're going to have a look at is how to solve problems like this.
This is the next page.
Oh, yep.
Now, what is your
I'm sneaky like that. I do the pages in order.
New topic, right, teacher?
That's right. Guys, why do you think I'm trying to trick you one day? Like one day do you think I'm going to come in and say, we're going to skip 10 pages and do an old topic.
No, you didn't say
Next page, a new topic.
You just said the topic first.
One linear and one quadratic on the next page. New topic. Let's begin. Right. So we have seen how to solve two linear equations. What are the methods we have for solving two linears? We have graph. What else? The methods. Come on. No, the methods. The name of the methods. We can use a graph. What else? This isn't the right word. Elimination. Elimination, yeah. Substitution and Gaussian. Gaussian we don't like. We can use two of those methods for these problems. We can use graph or we can use substitution. Okay? Now before I start, this is not the same as linear, because in linear, how many answers do you have? One. But how many answers could you have here?
Two.
You could have two, because this is linear and this grace is called, what's this one called? This one? Quadratic. So you could have two answers here. Yeah? You make your teacher sad. So sad. Okay, so like I said, we can use graph or substitution. So let's use substitution. If you look here, you already have y.
Yeah.
So what you can do is replace this y with that. So you get x plus 1 equals x squared minus 4x plus 1. So you get x squared minus 5x. In this case, the 1's cancel, so it's a 0 if you want, equals 0. And grace, what is this called?
Square. Oh, no.
No.
Quadratic.
Thank you. This is a quadratic. So how many answers could it have? Could have two. Right. If you want, you can just use the formula. If you want, I don't care. And you get two answers: x equals 0 or x equals 5.
Why don't factorize it?
I said I don't care. You can factorize it. You can use the formula. Like I said, whatever makes you happy. I'm not picky. Now, how can I find the y, Amanda? How can I find the y?
See?
The y. How can I get y?
Put the x into the equation.
Yeah, which one would you pick? Which equation?
Y equal x plus 1.
Yeah, y.
Easy.
Easy, yeah. So, if we put these values in here, I get y equals 1 or y equals 6. So, like I promised, we have two answers. No, bad teacher. 0, 1 or 5, 6. So as you can see, we can use the substitution method here. Yep. I'm going to draw these now so you can see it on the graph. Well, when you're ready. No Starbucks today? No Starbucks?
No money.
No money, yeah, it's a problem. Starbucks, you know Starbucks.
No coffee today.
No coffee today. No hot chocolate. No cappuccino.
No.
Nothing. Just hot water?
Yeah.
Yes. Okay, can I go to the graph now?
Yeah.
Yep. Right, so let's have a look at the graph. So the first one is y equal... Oh, actually, before I draw it, let me roughly draw it first. So if you look, we have, let's see, 0, 1, which would be about here, and then 5, 6, which would be something like here. So a very rough sketch. The first graph is linear, so it goes like this. And Grace, the second graph is called what? This graph? Whoops. This one here? I'm sure someone was helping you there. Quadratic. And is it this shape, U, or a hill?
No.
U shape, yeah. So it means that the quadratic would look like this. So this is what the graph should look like. Alright, let's have a check. Y equals x minus 1, y equals x squared minus 4x minus 1. Draw. Did I type something in wrong? X minus 1. What the heck happened?
Plus 1.
Oh, I did plus 1. So sorry. So now I have to draw it again. That. Oh. What?
Eureka.
Did I write these down wrong? X plus, plus 1 for the other one as well. Oh. Plus 1. There we go. One more time.
X minus.
No, this is my own example. Teacher is confused. It hurts itself in its confusion. X plus 1, x squared minus 4x plus 1. Is that it? Oh yeah. Yeah, pretty similar. Yeah. My graph, it's not perfect, I know. What's the big difference between this graph and the one I drew? Yeah, I didn't... It actually goes much further down. But I mean, that's not important. I just wanted a rough picture of what's happening. Okay.
How can I know the quadratic? How do I know it's hill or U?
Oh, you know this, Karar. You know this. In fact, I'm sure you've told me many times.
Not the linear.
The quadratic you just said.
Yeah.
How do you know, KJ, how do you know if it's this shape or this shape?
If the A is positive or negative.
Oh, negative.
Yeah, but you know this. You know this. Yeah. Alright, let's do another example now. But this time more difficult. Yeah, can I go on? Yep, okay. So let's say we have something like this. 2x minus 11y plus... Oh, well, just before I go on actually, can anybody answer this for me? Just tell me if you know. Will these problems always have two answers?
Maybe.
No.
No. What are the possibilities?
Maybe.
No.
Maybe no answer? Yeah. So if there's no answer, it looks like this.
Maybe it's 3 points.
Not 3 points. Here's two answers. Are these the only possibilities?
No.
No, there's one more possibility. One answer.
Yes.
And in English, there's a word, a special word when this happens. Yeah, this is called a tangent line.
Yeah, it's only touch.
Once.
Yeah.
It only touches once. And then next time it gets into trouble if it touches. So it only touches once. Yeah.
You have to be very clear while drawing it.
Huh?
You have to be very clear while drawing it.
Oh yes. For sure. Okay, can I go on now to the more difficult example?
Yes.
Great. Yeah, okay. Did Colin talk to you about maybe having a little notebook for words? This is it? This is just physics though. Where's your maths? Oh, I see. Ah. Good. Good. Oh, this is good. Quadratic, yeah. Third, yeah. Okay, we need more.
Yeah.
So, for today, here's another new word, tangent line. Yeah?
I will write down.
You'll do it later, yeah?
Yes.
Okay, good. Alright. Right, next example now. 2x minus 11y plus 54 equals 0. 4x squared plus xy minus 5y squared equals 0. Right, why did I say this one is more difficult? What's making it more difficult here?
Because we have two words.
Implicit function.
That's true. But just break it down to me simply. Why is this more difficult than the previous one? What's the first problem?
Why?
Yeah. The linear equation, what do you need to do? Make y the subject. You have to rearrange it. And also there's now a second problem. What is the problem with the second equation that makes it more difficult? There's an xy and
Y squared.
y squared is there also. So it's a little more difficult. Let's try it though. From 1, we can say that 2x plus 54 over 11 is equal to y. So what I did was, I took this to the right and made 11y and then divided by 11. So I got my y. Now, Grace, no, I'll stop picking on you, sorry. Yemi, what do I do next? If you know.
I thought you make y.
Say again?
I thought you make y.
Yeah, after you make y the subject, what's the next step?
Subtract.
I think you misspoke. Not subtract, what's the verb? No, not divide. Substitute. Replace. You replace the y in here and in here. Do you see that? Replace.
We need to make y checked as well. We need to make y checked.
Nope, not for the second one.
So you can put it in.
Just put it in, yeah.
See that, is it? What is that? 54.
Yes, it's 54.
It looks like a 5y.
Yeah, sorry. Happy?
Yes.
Great. Now, are you ready for me to substitute this in? Yeah. So you have now 4x squared plus xy minus 5y squared equals 0. KJ, did you write that down? Okay, can I scroll down? I can scroll down? Yep. So let's expand. 4x squared plus 2x squared plus 54x minus 5, 121, 4x squared plus 216x, 54 squared, just give me a calculator. 64 squared, 2916. Plus 2916. Okay. Now what should I do next, KJ? No? I could do that, but I'll make my life a little easier if I multiply everything by 121. Because this is a pain. So, I will get here 484x squared. When I put 121 here, that goes in 11 times. So I'll get 22x squared plus 594x. And then when I put 121 here, that's great because then they cancel. So now I have minus 20x squared plus 1080. Thank you. That would have been embarrassing later. And then 5 times that. Yeah. What's the one at the back here? Minus 2,900 times 5. 14,580. Thank you. It would have taken a while. Right, now let's put our terms together. So the x squareds will be 486. Yeah, x squared. What about this one minus this one? Minus 486x?
Yes.
Minus 14580 equals that. Now, I hope you can all see, obviously, 486 goes into all of them. So if we divide all of them by 486, I get x squared minus x, what's it, 7 is it? 8. What's this one? 14580 divided by 486. 3, is it?
No, 30.
30.
Yeah.
Minus 30 equals 0. Let's factorize. X minus 6, x minus 5 plus 5 equals 0. So you have two answers, x equals 6 or x equals minus 5.
What's 1456?
1456?
458.
14580. That's this one here,
Yeah.
which was 5 times this number. No, I need to find the y. So I know that y is 2x plus 54 over 11. So that means here y will be 6 here, is it? Hang on, 66 divided by 11 is 6. And then minus 5 is the other answer. So that's 4. So I have two answers, 6, 6 or minus 5, 4. Oh my goodness, 2a. 6, 6 minus 5, 4. Yeah. It's long and it's messy. But it's the same method. What method am I using? What method? What's this method called? Substitution. Yeah? Can you use elimination? No. Gaussian? No. Graph? You shouldn't. Let's quickly draw the graph here. So the graph here will be like 6, 6, and then here will be your minus 5, 4. Here is the straight line. Oh! Sorry, this is forbidden. This graph is not on this course, so I won't draw it. This equation here, this is actually not really a quadratic, it's not this. And the reason is because it has the y squared and the xy in it. Yeah. So we won't draw that.
So there will be two curves,
Yes.
not in a course.
No.
Very scary.
Do you want to see them? They look like this. I'll show you anyways. Y equals, sorry, what is it? 4x squared plus xy minus 5y squared equals 0, right?
You have four same equations in all cases.
What are you talking about?
Y squared and x and y.
Huh? What are you saying?
The same equation like x and y squared in the equation.
Yeah. What's your question?
I'm saying both.
Well, what's your question?
They are the same equation. It's not in the course that we already have.
No, the graph is not in the course, that's all. Here's the graph. Yeah. And then the other one was 2x minus 11y plus 54. And here's this graph. So let me just zoom out. Uh-oh. Yeah, so you see why that's why there's two answers. But it's not a quadratic, it's some kind of weird quadratic. Let's zoom in. It's weird because I keep zooming in and it looks the same. Watch. Zoom out. Isn't that weird? It's like, dude, you're the same.
Yeah.
It looks like there's something here, doesn't it?
Yeah.
So let's zoom in. Not making any progress. Yeah, so it's a very strange graph. You can zoom in, zoom out, it looks the same. And there's actually a name for that type of graph in maths, if you want to look it up online. Fractal. Fractal are graphs that look the same even if you zoom in or zoom out. So they're weird. Yeah. Okay, let me mark off the ones I want you to do. Okay, in question number 1, I want you to do GHI. No, not GHD. GHI. Yeah. Yeah, that's 3. And then in number 2, DEF. DEF. And if you want something interesting, you could try G. If you're bored and you want to see something interesting, you could try G. Alright, so what we'll do is you can work on these now, or you can take a break for a couple of minutes. At 12 o'clock we'll start the next lesson, okay?